Good morning. So I did have a live Google Meet today and nobody hopped on. So I am going to go ahead and do a screencastify of the lesson today because you are going to be logging into a new resource. And so I want to make sure that you understand how to do this. So the first thing that you're going to do is on your Google Classroom, I've created a link right here, so you're going to click on that. And it's going to take you to this page right here. Now, when you go to log in, you're going to hit sign in with ClassLink. Because we have ClassLink, you're automatically connected. So you'll just hit sign in with ClassLink. Now, I've assigned two things for you today. The first one is going to be your lesson, and then the second one is going to be your assignment. So as you're going through this video with me, you're going to be going through the assignment, or sorry, the lesson. So you have the lesson right here, and then you have the actual assignment as well, I believe. Yes, assignment. If you don't see those, let me know. Then I will help you with that, but you should have two things. You should have the lesson, and then you should have an assignment. So lesson one, taking apart numbers and shapes, and then here's the actual assignment. So today what I'm going to go over with you is the actual lesson. So while you are watching this, have open your lesson and you can hit view. Now, you are going to get a grade today for the assignment. So if you don't do this, I can check it to see if you haven't completed it. None of you got on today, so that concerns me. But you will get a grade for the assignment because we are going to start reviewing. And so we're going to be reviewing the distributive property. So I am going to go ahead, and mine looks a little bit different than yours because I'm on the teacher end of it. So I'm going to go ahead and I am going to open up the lesson one. We're going to view. And the first thing that we're going to start with is, well, maybe if it loads, is we're going to start up with a warm-up. And you should see the same thing that I am seeing right now. So lesson one is taking apart numbers and shapes. So we're going to do an overview of the distributive property. And you guys have worked on Mathia. So, and we're going to continue working on Mathia. So we're going to do a lesson. We worked on Mathia a little bit. I kind of saw where you guys were. Now, some of you have stopped in the lessons, and I will be sending messages to you to let you know where you've stopped. You have to continue to finish those modules for Mathia. So what we're going to do is we're going to start off with a warm-up. So it says calculate the area of each rectangle and show your work. This is a fabulous review because we just did the geometry unit. We just finished the geometry unit this week. So you're going to put your work here and then you're going to put your answer here. So I'm going to do the first one with you. So for the work here, I'm looking at this rectangle, and I know from my star chart is I can go ahead and I can put that its area equals, and I'm just typing this in. I'm going to show you kind of how to use some things. Area equals base times height. So that's going to be my first set of work. But then I'm going to also look here, and it could be base times height. It could also be length times width. And I'm going to go ahead and I'm going to put those numbers in now. So I know that area equals, and I have 15 as my height and 6 as my base. So 6 times, and I'm actually going to use my character or my tools right here. So if I click on this right here, I can do times, which is the dot. That's what I'm going to use. You can also use an X. And then I'm going to put 15 in. And then over here where it says area, I'm going to go ahead and I'm going to do 15 times 6, which after I get my answer there, then I'm going to just type it in, but I'm also going to include my units. Okay, so 6 times 15 is going to be 90. So it's going to be 90. We're talking about area. So I know my unit of measure is inches. And then to get my squared, I'm going to hit this X with the squared above at the top, and it kind of moves it up, the cursor, and I'm going to put 2, and then I'm done. And then I can hit save, and then I'm going to hit next. So this is the save button. It's not showing because I've got some things down here, but if I click on this, it's going to save my answer, and then I'm going to go to next. So what I would like you to do is, I modeled the first one for you. I want you to do warm-up question number 2, just how I did it. And I will check your lesson at the end of this, and I will check your assignment too. So what I want you to do is write your equation at the top, and then fill in the numbers. You are looking at this second shape right here. So your base is 12 yards and your height is 9. And then once you solve, make sure you put your units as well. All right, so our learning goals for today. So the first one, and I will look over your answers that you submit to me. All right, so your learning goals for today are to write, read, and evaluate equivalent numeric expressions, identify the adjacent side lengths of a rectangle as factors of area value, which we just finished in our geometry unit. We're going to identify parts of an expression, such as the product and the factors. And then we're going to also write equivalent numeric expressions for the area of a rectangle by decomposing one side length into a sum of 2 or more numbers. And then the last thing, which is the heavy hitter, is to apply the distributive property to rewrite the product of 2 factors. So we're kind of merging what we learned in our geometry unit with our distributive property. And it's been a couple of months since we've done distributive property, but you have been working on it in Matthew as well. So our key terms today are, I should say, numeric expression. Numeric is just a fancy word for numbers. And then we know that an expression is anything that doesn't have that equal sign. So it could be 2 plus 3, 3x. This doesn't have that, that equal sign, that it's equivalent to something. Our equation is where we have 2 expressions, and that's set equal to each other. And then we also have the distributive property. So you know how our essential statement or question is, you know how to operate with numbers using different strategies. We've done it this year. We've taken them apart before the operate can highlight important information or to make calculations easier. So sometimes when we're solving, we decide to chunk something or break it apart. So for example, if I'm dividing 120 by 60, we know that we can drop those zeros, and then I can go ahead and do 6 into 12, which is 2, and then add the 0 back on. That is a way that is making a calculation easier by taking something apart. We can also use the strategies to express number sentences in different ways. So something to think about is, how can you use these strategies to do this, to express number sentences in different ways? Sometimes we can break it apart to make it easier, little tiny steps compared to one big step. Okay, so we're going to get started. The first thing to do is, Callie is building a rectangular walkway up to her house. The width of the walkway is 5 feet and the length is 27 feet. She needs to calculate the area of the walkway to determine the amount of materials needed to build it. So the first thing they want us to do is to mark and label 2 different ways that we could divide an area model to determine the area of the walkway. I am going to model one for you, and then I want you to do one by yourself, okay? Because I want to see what you come up with. So they give us right here this rectangle. I'm going to move me over here so that we have some more space. Now, how we can do this is, I can use this little marker right here, but there are some tools. This one right here, if you click it, it makes dots. This one goes a dot to a dot, which creates a line. This is your pointer, and then if you want to write, you would use the pen, and then you can change your colors here. So you can do this a couple different ways. I'm going to show you how I did my first one, but when you do your second one, I want to see something different, but I will model how to do this. So some important information that we know, and I'm gonna do this in red. Well, maybe not. Let's see. So I know that the walkway is 5 feet. The width Oh, I can't highlight there. But what I could do is use this highlighting button. So up here we have some tools too. I'm going to use the highlight, and you have an eliminator, you've got calculators, you've got rulers, a protractor, sticky notes, and then this is to help you read. If you click it, it helps you. You can move it. And then you just click on it to get rid of it. So I'm going to actually use the highlighter because I have some important information. So I know that the width of the walkway is 5 feet and the length is 27. So that went ahead and highlighted it for me. So I'm going to go ahead and make a couple notes here. I'm going to use my marker here, and I'm going to do that the width is 5 feet, and then my length is 27. And I'm putting it up top because I'm going to have to do some other things at the bottom with it. Okay, so what they want us to do is to break this down into something a little bit easier. So I'm going to leave my 5 there because 5 is my width. But I want to think that number 27, can I break it up into 2 different numbers that would just make it easier? Because 27 times 5 quickly is it's not very easy. So I'm going to go ahead and I'm going to section. See if this does it. I've never used it. Oh yeah, not bad. Okay, it's not a straight line, but it's not bad. Oh, you can move it. See, this is the first time I've used this tool. Okay, so what I'm going to do is I'm going to section this off. So this would still remain 5, but then I'm going to take this 27 and I'm going to break it into 2 numbers. I'm going to break it into a 20 and then a 7 over here. So I've just taken the width, or sorry, the base or the length, and I've just cut it into 2 numbers. Okay, so I've done 20 and then 7. When we add that up, is 27. So now what I can think of is that I can quickly do 7 times 5 because multiplying by 5s is pretty easy. So 7 times 5 quickly is 35. So I'm just going to put my area in here. And then 5 times 20, well, 5 times 2 is 10, and then I go ahead and I add that other 0. Now, if I wanted to find the combined area of the entire rectangle, I would just add them together. So then that 100 plus 35 is 135. And that is much easier than having to do 5 times 27 because those are numbers that are kind of difficult. So I went ahead and I marked and labeled one way to do this. So when I hit next, it then says, determine the area of the subdivided parts of the model. Enter your text here. Well, I went ahead and I showed how to do that. So then I would go ahead and I would just put my answer as 135 feet. And then to get that squared, oh, it's not there. Did I miss it? Uh-oh, I can just do this then. Can't find it there. So we're going to hit squared. Or type it in because it's not showing here. Oh, wait, no. Nope, still not showing, which is totally fine. So we determined the area of the subdivided parts of the model. So I went ahead and did that. So I modeled one way that I could go ahead and break that. My width stays 5, but I can take that the 20 plus the 7, and I can add those together. So your job now is to do the second one. You're going to do exactly what I just did, but when you hit next, they're going to give you a second model, which is right here. You need to figure out another way that you can take that 27 and you can break it into 2 different numbers so that when you multiply and add it, it's easier than multiplying the 27 and the 5. And then again, you will go ahead and determine the area of the subdivided parts of the model right here with your final answer. And then what is the total area of the walkway? We just said that we know that it's 135. So if you do the second one and when you get a final answer, it doesn't equal 135 feet squared, we know that we did something wrong. So go back and look at how you broke up that number of 27, or you decomposed it, I should say. All right, so the numeric expression of 5 times 27 represents the area of the walkway from the getting started. A numeric expression, which was one of our vocabulary words or our focus words, is a mathematical phrase that contains numbers and operations. So the equation 5 times 27 equals 135 shows that the expression 5 times 27 is equal to the expression 135. So this is an expression, 135 is an expression, but when we set that equal sign, that's when it becomes an equation, which is a mathematical sentence that uses an equal sign to show that 2 or more quantities are the same or equal to one All right, so we're going to be doing a lot more of this. So the next thing that we're going to do is we're going to be looking at another model. So Sandy created the area model to determine the area of Callie's walkway. So she went ahead and she did the 20 and the 7, which is exactly what I did. So she did the 27, she broke it up, and she did 20 and 7, multiplied the 20 and the 5, the 7 and the 5, and then added them together. So what we're going to do is we're going to look at this, and we've broken it down of how we can put it into expressions and then later figure out what it is. So we're going to replace the underscores with our answers. So right here we have 5 times 27, which was the initial one, but we broke that into something different. We went ahead and we pulled the 5 to the side, and it's the same thing as if we were to multiply it by 20. So you're going to click on that where that is, the line, and we're going to replace that with 20 plus 7 because we added this 20 and the 7 together. Now, when we do that, this is using that distributive property. We went ahead and we multiplied it 5 times 20. In my model, this is the exact one that I did. We did the 5 times the 20, and we said that that was 100. So right here, 5 times, first we did the 20. And then on the second one, we did the 5, because that was just for this area. We did the 5 times the 7. So I'm going to put that 7 in. We're just breaking it down. This is our picture. This is our number thinking. Okay, but then now I'm going to go ahead and I'm going to do this. We said right here, this area of this broken apart rectangle, 5 times 20, that was 100. And then the second one was 5 times 7, which was 35. And then we went ahead and we just added 135 and we got 135. So that was just simpler than doing the initial 27 times 5. And then you're going to go ahead and you're going to hit save answer and then click next. Make sure you save your answer each time, and then so that it saves it, and then you enter or go to the next page. I just don't want to take the chance. It's new. I was hoping that someone would be on today so that we could look at it from your end too. But I'm assuming that it looks very similar to that. All right, so you just used the distributive property. We went ahead and distributed that 5 to that 20. We multiplied it. And then we distributed the 5 to the 7 and multiplied it. And we added it together. And that's exactly what the distributive property is. So what they're giving us right here is a model, just like what we said. And they're saying over here the distributive property of multiplication and over addition states that for any numbers a, b, and c, that the equation a, look down here, a times b plus c will equal ab plus ac. Okay, so what I want you to do right here is, given that information, I want you to go ahead and write me at least two sentences in this box to explain the distributive property using this area model. Okay, we just did an actual example, but I also want you, with just using this model and what we just discussed and what we just went through and modeled and did, I want you to explain the distributive property to me. You know what distributive property is. We've used it this year. I've also just did a little mini lesson on it, but I want you to explain it to me. This model is given to you. Explain what you know about the distributive property and put it in here. Make sure you hit save your answer and then click next. All right, so here's an example, a worked example of the distributive property. Here's that 4, okay? We're going to go ahead and we're going to multiply it, because when we have a parenthesis, that is multiplication. So 4 times 2, and then we can't forget that addition, because if we forgot that addition sign, then we would be forgetting that other part of the triangle. And then 4 times 15, so we have the 4 times 2 right here, plus the 4 times 15. We can do the 4 times 2, and then we can do the 4 times 15, and then we can add them together, okay? And you can read and describe the expression in 4 times 2 plus 15 in different ways. You could say 4 times the quantity of 2 plus 15, so 4 times the parentheses being the quantity, 2 plus 15. You could also say 4 times the sum of 2 and 15, because you're multiplying 4 times 2 plus 15, sum meaning add. Or you can say that the product of 4 and the sum of 2 and 15. Okay? So you can also describe this expression right here as 4 times 2 plus 15 is the product of two factors. The quantity 2 plus 15 is both a single factor and the sum of two terms. So just different ways. So what we're going to do is we're going to have some practice. So it says fill in the missing addend in each blank that makes the equation true. So I'm going to do A and B with you, and then it's your job to do C and D. Do A and B with me right now, but then in just a minute, I want you to do C and D on your own, and then save and hit next so that you can submit it and I can look over it. So right here, this is our first part of the expression. This is our second expression. So we need to, eventually these are going to be an equation, but we got to figure out what are we doing here? So they went ahead and they have this 7 pulled out. So we have to think, okay, our end goal is 21, and this is multiplication. So 7 times something gives me 21. Well, 7 times 2 is 14. 7 times 3 is 21. So 7 times 3 equals 21 plus 7 times 10 is 70. So in A, I'm going to just put my answer that I need to put in for that blank, which is going to be 3. Okay, we're just decomposing it. So I'm going to put 3 in there. Now we're going to look at this one. They went ahead and they have the 3 out here. We know that this parenthesis is to multiply, but let's look on the other side of our equal sign to figure out what our end goal is. So I have 36 here. So I have to figure out 3 times something gives me 36. Well, I can go ahead and divide 36 by 3 because it's the inverse or the opposite. So I know that if I take 36 and divide it by 3, that is going to be 12. And 12 times 3 is 36. So, and then if I check again, if I do 3 times 15, that is 45. So I know that I did that correctly, because then I would just combine the 36 and the 45. So here is my 12. So what I want you to do is they went ahead and they've done the same thing, but this time they did the second number. So 8 times 2 is 16. So then you have to figure out, there's your plus sign. 8 times what is going to give me 56. So make sure that you type those into C and D, and then you hit save your answer and then go to next. I modeled A and B. I would like you to do C and D, and I will look it over. All right, so same example showing that distributive property. What we're going to do is we're going to rewrite a factor as a sum of two terms in the expression and use the distributive property to verify the product. So now we're going to take this one step further. We're going to look at this and we're going to figure out what to do. So what I'm going to do here is I'm going to do this first one with you, and then you're going to do the remaining by yourself because there are some examples. So the first thing I'm going to do is I'm going to go ahead and I'm going to pull out that 4. I'm going to rewrite this. So right now, this right here, I want to make it look like this is distributive property. So I'm going to pull out that 4, that factor of 4, or if you're thinking about it in the model, you would think about that as that 4 is your width. Okay, that's what we're multiplying everything by. So I'm going to go ahead and do 4. Now I'm going to think to myself, how am I going to break up 17? I have my 4. How can I break up 17? Well, in my brain, 17, the easiest to break up is just 10 plus 7. That's what works for me. 10 plus 7. So I've rewritten this as 4 times 10 plus 7. So you're going to take that first number out, and then you're going to take the second number, and you're going to figure out how can I break that up to make it easier? Because multiplying 4 times 17, that's pretty difficult. But in my mind, 4 times 10 is 40, 7 times 4 is 28, and then I add 40 and 28, and I get 68. That's quicker. I've just decomposed it to make it easier for my brain to work it. Okay, more compatible numbers. So I rewrote this as a factor of sum of two terms, and then it says to use the distributive property to find that answer. So down here, I'm going to show 4 times 10, and then plus 4 times 7. I'll put my equal sign. And then I'm going to go ahead and I'm actually going to do this. 10 times 4 is 40, plus 4 times 7 is 28, and then 40 plus 27, 68. So I just proved that I can go ahead and decompose that second number like we did in the model to find the area. I can decompose that number into easier numbers, and then I can use the distributive property to get that 68. So I have done this one as a sample for you. Remember to save the answer and then hit next. But I want you to do this 9 times 34. I want you to do this one by yourself. So you're going to think about your 9 is your multiplication or your width, and then think, how can you break up 34? Okay. And then you have 3 times 29 as well. Again, when you're finished with this one, please be sure to hit save and next. All right, the next part is actually true and false. So it's utilizing what we just practiced with the models and then rewriting and using that distributive property. And you're going to identify if the statement is true or false. So this first one, let's look at this. We know that we can take this 3 and distribute it with the 2 by multiplying. So 3 times 2, that's right there, plus 4. Ooh, it didn't do the 3 times the 4. So if we're thinking about it in that model, we only did that first part of it. We sectioned it off in that area model of the rectangle. We only found one area. We didn't go ahead and multiply that width to that second part of the length, so we can't figure out the total area. So this one is false because they forgot to do the 3 times the 4. They didn't fully distribute that. And then we're going to hit submit answer, and it gives us instant feedback that is correct. Okay? Now, if the statement was false, how could we rewrite it to make it true? So as you're working through these, they're going to ask these questions. So our last one was false. We said this was false. So they want us to make it true. So what you're going to do is you're going to type in, let's see, we're going to type in right there, and we're going to make it true. So let's go ahead and make this true. So 3 times the 2 plus 4, we know that we have to go ahead and do the 3 times the 2. So 3, if I can, there's the multiplication symbol, 2. And then we're going to do plus, then we're going to show the 3 times the 4. So 3 times 4. And that's how we make it true. Now, it may be you have chosen true, and if it is, you would just hit save answer, and then you would hit the next button. So if they're false, you're going to fix them. If they're true, then you're just going to hit save and move on. So I'm going to hit save, and then I'm going to move on to my next one. All right, so the next one, identify the statement as true or false. Well, let's look. We have 6 times 10 plus 5. Well, 6 times 10, that's where it's showing there, plus 6 times 5, which is right there. So this one is true. They went ahead and fully used that distributive property. They multiplied by the first rectangle and then the second rectangle if we're using an area model. So this one, you're going to submit your answer. It is correct. It's true. So then we would go to the save the answer and click next. This one's true, so we have nothing to fix. So you're going to hit save and then next. So I did the first 2. You have 3 more. 3 more. So I want you to do C, D, and E. And I'm just going to hit next if it lets me. It does. And remember, if it's wrong, fix it. All right. So this is the next one is we're going to talk about the floor. This is you. So let's talk about how we're going to do this. So you can apply the distributive property to solve real world problems. So this is a very real world problem. Tyler's setting up a gym floor for an after school program. He wants to include rectangular area for playing volleyball, another for dodgeball, and he also wants to have an area where kids who like to play board games or they just like to sit and read. The gym floor is already 50 feet by 84 feet or 4,200 square feet. So they're giving us this and they're saying that here's your rectangle that represents the gym floor. You're going to show how Tyler could split up the gym floor. So again, let me pull out my highlighter because there's a lot of information in here that I need. So I know that we need a rectangular area for volleyball and dodgeball, and then kids who want to play board games or just sit. And we also know that the gym floor is, oh, it didn't highlight. The gym floor, the dimensions of the gym floor. We know that it's 50 by 80. So let me pull up this so that I can write some notes here. So I know that my 50 feet by 84. So this is going to be my 84. And then my width is going to be my 50. So most likely nothing's going to change with my 50 feet because 50 is my width. Okay. But I can go ahead and I can break apart that 84. So we're going to do the same thing. So I have to think in my head, what is going to be the best way to break this up? So to me, when I think about this, I need to have the area for the board games or just sit or reading. That's got to be my smallest area because the other two are going to be being used for dodgeball and volleyball. That's what I'm thinking in my brain. So I'm going to go ahead and I am going to section this off. So here's my first one. It's not very straight. So this right here is going to be my area. Right here is going to be for my reading area. Then I'm going to take this and I'm just going to section it off again. Now this is not to scale. I am just doing the best that I can. Okay, so there's my second one. So we know that this is going to be the reading area. And then this will be the dodgeball and this will be the volleyball. So I have to take this 84 and I have to decompose it or break it down or make it easier. So in my brain, I see the reading being 10. And then I see the dodgeball being 34. And then I see this being 40. Okay. Now when you do yours different. Don't just copy mine. Do yours different. Maybe you can break that up a little differently. This is the way it worked in my brain. Okay, so the first thing that they want us to do is the rectangular represents the gym floor, show how we could split it. So I did this. My 50 stays the same, but I can take this 84 right here and decompose it into 10, 34, and 40. So 10 plus 34 is 44, plus 40 is 84, and that's what I needed. Again, when you do yours, try something different. Remember to hit save and then next. Now they want you to go ahead and they want you to represent your diagram that we just did using the distributive property. So let me go back real quick. So when we use the distributive property to find the area of this section right here, we're going to do 50 times 10. So we would do 50 times 10, and that would give us this area in the reading section. Then we would need to add that to the 50 times 34 to get the area of the dodgeball section. Then we would need to add that to 50 times the 40 because that 50 times the 40 is going to give us the volleyball. And then when we add that up, we add this area, and this area, then that's going to give us our entire area of that rectangle or of the gym. So let's go ahead and show what we just did right there. So we would have the 50 times, we have 40 plus, that was our first section, 34 plus 10. So this was the width, and then these were our breaking this, the 84 broken up. Okay, then we would go ahead and we would use that distributive property. So first we said that we would have to do the 50 times the 40, just like we did in the picture. So here we're going to do 50 times 40 plus, then we would have to do 50 times 34 because that was the dodgeball section. So we would show that 50 times 34 and then plus 50 times 10, which was the reading section. Okay. And then we're going to go ahead and we're actually going to solve that. So I'm going to put my equal sign. All right, so 50 times 40. So remember, we can drop the zeros. 5 times 4 is 20, and then add the 2 zeros back. So 20, and then add 2 zeros. So that's quick. It's 2,000. Plus, because we can't forget that plus. Now we're going to do 50 times 34. So 50 times 34 is 1,700. Plus, now I have to do 50 times 10, which is 500. Okay, so here's where I went ahead and did the distributive property, and now I can add this. So when I add 2,000 plus 1,700, I get 3,700, and then 3,700 plus 500 equals that 4,200, and that should be my total area, which I said over here was the entire area of the gym, because I took the reading section area, the dodgeball section of the area, and the volleyball section of the area, and then I added them and got 4,200. It's square feet. Remember to hit save and next. So what you're going to do is here is the area of the volleyball space and the dodgeball space. So whatever numbers that you used, so for example, in mine, I went ahead and the area of the volleyball space was, I believe, yeah, so it was 50 times, oops, times 34, and then that equals, and then you'll put your answer, which we said that was, oh, sorry, no, that was 40, my bad. This is 40, and we said that that was 2,000. And then my explanation, you would make an explanation. So my explanation was the width of the volleyball space was 50, and the length or base, because length and base are the same, was 40. So multiplying 50 times 40 equals 2,000 square feet for the area of the volleyball space. Okay, so then you would do your explanation of the dodgeball space and then the reading space. Hit save and then next. Okay, so I am finished with the lesson. This is just the lesson, and I'm sad that you're going to have to watch this, do the lesson, and then you actually have an assignment too. So this concludes your lesson. So it tells you how many of the questions were answered. So you want to make sure that 26 of 26 have been answered, okay? And it will tell you which ones were not answered by being gray. So if you're missing one, you can click on it and go back, and you can go ahead and answer those ones, and then you're done. So make sure everything is blue. And then the second thing that you're going to do is when you're finished with this and you've saved and turned anything in, this was your lesson, okay? This was your lesson. This is what I was going to do live, me doing this with you with practice, like if you were here at school. Now you need to go back after you finish and complete your lesson. You're going to go back and you're going to do the assignment, and it will look like this right here. Assignment, lesson 1, taking apart numbers and shapes. You will do the same thing. You will view it, start it. I don't know what it looks like on your end. It's going to either say view or start, and you're going to work through this, okay? Again, you are getting a grade for this, okay? So this works very similar to our lesson. You're going to hit next, and then you're going to start. Explain the distributive property in terms of composing and decomposing numbers. Just what we just did in our lesson. Explain it to me here so that I can see it. Remember to hit save answer and next. So you should have done the lesson and turned it in, make sure that all of the answers were complete. Everything will be blue. And then you're now doing the assignment, okay? I am taking a grade for these. So if you do not do it when I go in there to check them, later this week when I check, or hopefully tomorrow, if you did not do them, you will not get a grade for it. Okay, so I'm going to go ahead and hop off. If you have questions, please send me a private message. Also, if you need to do the Mathia pre-launch, you need to go back and you need to do that because we are going to be also working in Mathia too. All right, guys, let me know if you have any questions.